So let's design of rectangular column for the axial loading conditions. So column is there, the load is acting along the CG of the column. For that case, how we are going to design? So column size is given 600 into 400 mm. So let's take, this is 600 mm, this is 400 mm. So along the x-axis, this is y-axis. So dx dy, dx into dy along the x-axis, along the y-axis. Next, service load is given. So this point is very important. Axial service load. Axial service load is nothing but the load is acting along the center, along the axis point. So 2000 kilonewton. Unsupported length, the edges, the conditions between the distance between the edges. Unsupported length 3 meter is given. So here to here, the L value is 3 meter. Then column is braced against side sway. So they provided the bracing to restrict the side sway. So next, M20 grade of is given. So characteristic compression of the strength FCK is 20 Newton per mm square. Tensile stress Fy is given. Steel 415 Newton per mm square is given. So these are the details as provided for the design of rectangular column. We will go step by step manner. First of all, we have to check the slenderness ratio, whether it is a L by D ratio is less than 12 or greater than 12. So first, the length is provided, unsupported length 3. So 3000 divided by D. This is the least lateral dimension for 600 into 400, which is least 400 mm is the least dimension. So 3000 divided by 400, which is equal to 7.5. So less than 12. So hence column is designed as short column. Next step, minimum eccentricity. We have to confirm whether it is greater than E minimum, because of due to the construction point of view, we cannot execute the same exact point. So we have to consider the eccentricity. So along the both the axis, x-axis and as well as the y-axis, we have to find it out. So first of all, we will find the x-axis, Ex minimum, L by 500 plus D by 30. So 3000 divided by 500 plus D is first x-axis. Along the x-axis 600 divided by 30, so 26, which is greater than the 20. Along the y-axis, Ey minimum 3000 divided by 500 plus 400. Along the y-axis, we having a 400, so 400 divided by 30, which is 19.33, almost equal to 20 mm. So both axes we find it out, so it is almost greater than the 20 mm. And also we have to check 0.05 times of D. So in case of if it is greater than E minimum, we can go for the formula. So 0.05 times of dx means 0.05 into 630. So it is greater than Ex minimum. 0.05 of dy, 0.05 into 400, so 20, which is almost equal to 20. So both is greater than the E eccentricity, minimum eccentricity. So we have to go for that formula, PU formula. So in our question, in our data, they provided the axial service load only. So we have to convert it in terms of ultimate load. So PU equal to 1 point times of axial load. So that is 1.5 times 2000. We have to apply 3000 kilonewton PU value. So step number 5, longitudinal reinforcement. Longitudinal reinforcement, the formula is PU 0.4 FCK AG plus 0.67 Fy minus 0.4 FCK AS. Here AG is gross section, that is 600 into 400. So A is area of steel. We have to find out the longitudinal reinforcement only, that is area of steel. So substitute all the value, we will get the AS formula, AS value. So PU is 3000 kilonewton, 0.4, FCK is 20, AG 600 into 400. So 0.67 415 minus 0.4 into 20 into AS. This is the unknown value. So similar, we solve those details, solve the value, we will get the 4000 mm square. So we will provide the reinforcement and as well as the number of bars. So according to these conditions, say AST provided 6 numbers 25 mm dia bar then 4 numbers 20 mm dia bars if you have provided, the value of area is satisfied 4220 mm square. That is how much we got, how much we provided, it should be greater. So 4202 mm square, which is greater than the actually required, so it is greater. So we also check the AST minimum. So AST minimum formula, we know that 0.8 percentage is minimum, maximum is 6 percentage. We have to check it out. 0.8 percentage of cross section. So 0.8 divided by 100 into 600 into 400. So 1920 mm square is enough, but we provided the 4000 mm square. So we need 4000 mm square. So we provided 4202 mm square. So which is less than the AST provided. So no, hence it is satisfied. Next we have to find out the distribution reinforcement bar, that is lateral ties. It should not less than 1/4 of main reinforcement. So 1/4 into, we using 25 mm and as well as 20 mm. Which is greater, we have to apply that 25, which is having a 6.25 mm square. So we provide 8 mm dia bar. 8 mm dia bar. Next we have to find out the spacing, that is pitch. We having a 4 condition is there. First condition is least lateral dimension. So for the column section, we having a 600 into 400. Among this value, we having a 400 mm is the least lateral dimension. Then second condition is 16 times of smallest main reinforcement. Here we are using two different reinforcement, 25 and 20. Which is smallest reinforcement is 20. So 16 into 20, we having a 320 mm. This is the second condition. Then third condition, 48 times of lateral ties. So 48 into 8 mm. So 8 mm, which is equal to 384 mm. Next, the fourth condition is should not less than the 300 mm. So 300 mm. So among the which is less, 400 mm, 320 mm, 384, 300, which is less. So 300 mm we have to maintain the spacing between the lateral ties. Let's go for a reinforcement diagram. This is our 600 into 400 mm cross section area. Along the we provided the along the corners, along the edges we provide the 25 mm dia bar, 6 numbers. So one end we provide 3 numbers, another end we provide 3 numbers. So 6 number of bars, 25 mm dia bar. Then in between, middle of the column, we provided the 4 numbers of 20 mm dia bars. Then lateral dies is 8 mm dia bar, 300 mm spacing. So this is the reinforcement diagram of design of rectangular column. Thank you.